Assalamualaikum warahmatullahi wabarakatuh. My name is Akbar Devari, and today I would like to presentations about artificial life. Artificial life has had a close relationship with the community of scientists working on the origins of life. Similar to the subdivision of artificial life into two rather distinct areas focused on either individuals' autonomy or population evolutions. There have been two major theories about the origins of life, known as the metabolist first and replicator first. The former typically views the origin of life as relates to the emergence of self-production and self-maintaining far from equilibrium structures. For example, based on the principles of autopoiesis, autocalysis network, and regime diffusing system. The latter approach, which has received more intense attention in mainstream science, prefers to identify the origin of life with the beginning of evolution by natural selection. Its classic formulation is a RNA world hypothesis, which has been generalized to the idea of natural sections in mechanical evolution. In recent work, these two approaches can no longer be clearly distinguished, as both autonomy and evolution are to be necessary for life. Metabolism first approach have accepted the necessity of an information capacity to enable open-ended evolution, even if it's in terms of a prebiotic composite genome. Replicator first approach, on the other hand, had to make research to remember boundaries and metabolic activity. For example, to give rise to individuals protocols capable of competitions. More recently, a new database has arisen about the role of movement and adaptive behavior in the origins of a topic that had long been ignored by both metabolism and replicator first approach. Indeed, one of the major open challenges in this area is to better understand the engineering of second-order emergence, that is, how to scientists the underlying condition for the emergence of an individual that, in interaction with its environment, gives rise to interest behavior. Here, we therefore find the flip side of the problem faced by evolution robots. While models of the origin of life must somehow make its system more interactive, robotic has to somehow make their system more autonomous. It is likely that attempts at integrating biological autonomy, adaptive behavior, and evolution into a model will we will continue to improve, which would at the same time mean integrated of the various subfields of life. The integration of life and mind on various timescales is also supported by ongoing development in the philosophy of mind and cognitive sciences, which is increasingly realizing the many ways in which mind is inseparable from the living body. At a high level of abstractions, ecological studies in life can be described as interactions between the individuals from different species and with their environment. Evolution involves species interaction across generating have strong relations with ecology, seems creature Or one example of evolutions, these creatures compete for a research and evolving interesting morphologies and behavior, and a relevant topic within evolutions is the red queen effects, where species evolutions affects the fitness of other species, leading to arms races, which can promote the evolution of complex traits. That's all for me. Happy watching and thank you.